Test. Hey, I think there's just one active homework out. Homework 10 due tonight at midnight. Okay. And I'm going to be on the board, but what I'm doing on the board you should be able to do on your notes there on the worksheets. The first thing we're doing is we're going to use the worksheet. It says worksheet on using the sign test to study survey responses. This uses the same pecan data that you're doing on the homework 8, where people did a blind taste test and they tasted the Kanza pecans, the pony pecans, and the native pecans, and they rated the flavor of it. And what you're going to find is that the bar chart is going to show that people like the Kanzas more than natives, meaning it's going to have a higher rating than the natives. But one thing we want to do is we want to say, well, how do we, you compare any two pecans and ask people to do ratings, you're never going to get a situation where the average ratings is like exactly the same to like the third decimal point. And so you need some kind of way of saying, okay, this pecan got a higher rating. Is it big enough for us to say there's a real difference? And what we do is we say, is this big enough to say that it didn't get a higher rating just by random chance? And remember what we try to say there is we say, okay, if we got 54% people prefer Kanza, would that be consistent if everybody just flipped a coin to determine which one they like better? That's the kind of thought experiment you do. Another way of saying it is like if I gave out a survey and I had to guess what people would have gotten, and what if I just flipped a coin to see which one would they prefer? Would that be inconsistent with what people gave? And so we're going to show you real quick how to do a little sign test for that. And this is pretty easy. This is you've done statistical, you certainly did statistical test in your stats course that you took a long time ago and you hated and you forgot. This one we're going to do is a lot easier. This is a test where you don't need to do things like assume a normal distribution or anything like that. And so what we do, this worksheet here starts with a scenario where you can see I've got data on the flavor of the Kanza pecan. Some people would put 4, some people would put 5, and a higher rating means they like it more. And then we have the native there. And then what I did was I said, okay, what I want to do is instead of just comparing the average ratings, I want to go in and count how many times each person liked the Kanza more than the native. And if that percentage, the people who like the Kanza more than the native, is really bigger than 50%, then it seemed like they really did like it better. That it wasn't just a coin flip to determine which one they liked better. And we're going to go through here and just show how you do this little sign test for that. So number one, then, and you can see up here I have the formulas I use in Excel, an if statement. First thing I did was I wanted to say for the first observation there, which is in row 14, the person rated the Kanza 9, which is like extremely, and they rated the native 4. So that one, they really liked the Kanza better than the native. And so in column C, there's a 1 because we're saying, is the Kanza rated higher than a native? Yes, it's 1. And if they didn't like the Kanza better, that would be a 0. So I've just got an if statement for that. But as you're going to see, we also want to know the instances in which they were tied. And so you can see in the third row, they gave an 8 of rating to both Kanza and native. And so there was a tie there. And then the total number of observations there was 152. And so for number 1, to perform a sign test, first answer the following questions. Total number of observations, that's 152. It was given by that count statement above. So number of observations, 152. Number of times Kanza was rated higher was 81. And then we say, I'm going to skip one, number of times they were rated the same. That was 36. Now we only calculated number of times cons are rated higher or rated the same. Anything else would be an instance where the native was rated higher. So to calculate that, for the number of times a native was raised higher, I just say there were 152 total taste tests. I'm going to subtract 81 because 81 people like the Kanza better. I'm going to subtract 36 because 36 gave them both the equal ranking, and so that leaves me with 35. So the answer for one there is 152, 81, 35, 36. Out of the 152 people, 81 said the Kanza was better, 35 said the native was better, and 36 people rated about the same. Now certainly, when you just look at that, it looks like when we're talking about the average person, they like the Kanza better. But we're going to do a more rigorous statistical test just to see if that's really the case. And so that's where we go to number 2. Now remember, what we're trying to do is we're saying, okay, so we got a lot of people like the Kanza better. How different is that response than what we might expect to see if people just decided which one they like better with a coin flip? And now there are no ties in a coin flip, so what we want to do is we want to go in and redistribute some of those ties. So what we're going to do on number 2, it says we redistribute the equal ratings equally among the Kanza and the native. If there's an odd number of ties, just discard one. And so our total number of observations is still the same, 152. Number times Kanza better is going to equal, well, first we had 81 people who definitely said they like the Kanza better. But then we take all those ties and we're just going to equally distribute them between Kanza and native, which is what you would expect with a coin flip. You know, with a regular coin flip, half the time they're going to like one better, half the time they're going to like the other better. And there were 36 ties. We're going to give half of them to the Kanza, and so that gives us 99 times people like the Kanza better. And from now on, I'm just focusing on the Kanza because more people liked it, and all I want to know is, did enough people like it that much more that it's really so far above 50% liking them each about the same that we can call it superior? That's what we're asking. And then the percent times the percent Kanza better is, there was 99 times they liked it better, the Kanza better. There was 152 total taste tests, and that's 0.65. Or 65%. So what we're saying there is when we ask the 152 which people they like better, and we force people who gave an equal rating just to flip a coin to see which one they like better, we find that 65% of people liked the Kanza better. And then we want to say, well, so we want to say, is this real? You know, is this a real preference, or is this just an artifact of randomness? And we answer that by saying, if we just had them flip a coin to see which one they like better, how likely would it be that we got a number as high as 65%? And if a lot of times you find out just flipping a coin would give you 65%, you'd say that's not high enough to say the difference is real, because you're saying it could have easily happened just from randomness. And you don't have to do hardly any calculations, because I do these things for you. In the textbook excerpt, you have this table there. And this is a table for probabilities for the duo trio test. That's something Dr. Van Overbeek's going to cover, but it's kind of the same thing as here. You just, it's like a 1-0 is the percent high enough to say it really is different from 50%. And then we have in one column, it says number of coin tosses. And in the second column, 95% of the time, a coin toss will result in a heads a maximum of blank of the time. And I'm going to write this on the board in just a minute, but let me say it first. What we're going to do is we're going to say, okay, we have 152 taste tests. And these were real taste tests, by the way. Well, that's between 100 and 200 coin tosses. And then we look and we say, well, if you had 100 people flip a coin to choose which one they like better, 95% of the time, you won't get a percent that exceeds 58%. And so if you got one that said 59%, you would only expect that less than 5% of the time. 60%, less than 5% of the time. So again, if you have 100 people flipping a coin to determine which pecan they like better, 95% of the time, you'll never see a percentage higher than 58%, which means that's actually a pretty big number. You wouldn't expect to see this with a coin toss. You could get 100% with a coin toss, but this is very unlikely to happen by randomness. So I'm going to write the answer here. Is that the easiest statistical test you've ever done? Yes, Dr. Norwood. All right. Okay. And so this is my answer for number 5. All things considered, should we conclude the Kanza pecan tastes better than the native pecan in blind taste tests? The answer is yes. With between 100 and 200 taste tests, well, let's say coin flips, ,95% of the time, the maximum number of heads would be between 56 to 58%. 56 when you have 100 coin flips or taste tests, 58 when you have 200 of them. This is less than 65%. So it appears most really do like Kanza better. Kanza better than natives. And you know, if you're looking at that and you just see if it feels like that's an odd way of phrasing something, and you're thinking like, what kind of person talks like this? You know, this is just an odd way of approaching something. That is a statistical test. I mean, you know, that's why statistical tests have this unusual vocabulary. You might remember like the null hypothesis, reject the null versus fail to reject the null. And because it is unusual, this isn't how we usually think about things, but it's the only way you can really approach things to figure out, is this real or did it happen just because of randomness? And it may seem like there's kind of a gray area there, because there's always a gray area when it comes to statistics, because you can flip a coin 100 times and get heads every time. That is within the realm of possibility. And so for your projects, when you're talking about how you want to analyze the results, if you have taste tests like this, you can say one way you're going to show the results is through a bar chart showing the average ratings, and then you're going to do a sign test to determine if some are statistically different. Unless there's some questions, we're going to go to the next worksheet. This is where you've done a thing called regression sum, not much. In 3213 you have. You'll do a lot of it if you go to grad school, but what I want to do is show you one way of how you can use a thing called regression to analyze certain survey results. In the last homework, I don't know, I think it might have been homework 10, you had to fill out that survey form. Did anybody notice what important question I failed to ask in the survey? What? Yeah, the name. So I pulled up the spreadsheet. It was going to go through, and I don't know who you. So when I talk with you about your projects, I'm going to have to ask you what your prototype is to go there. It's so easy to forget little things like that. But when you did that survey, you answered this one particular question shown on the worksheet on analyzing survey results using regression. The first one said, okay, what if you're coming to a package of large pecans with the improved variety produced in Oklahoma? Here's the statement: I would purchase this package of pecans, and you could go strongly disagree, neither, agree, or strongly agree. And then you did that for another package that had small pecans, improved variety produced in Oklahoma. And so there was these three attributes: the size of the pecans, whether they were improved or native, and whether they were produced in Oklahoma or imported from Mexico. And I randomized that on the questions, and then you gave me a rating. And then I took your rating and I estimated a regression to show you how you can analyze these results. And I also asked you how often you purchase pecans, and then I asked you your gender. Now, to analyze these, we're going to create some variables and a model. And so I have some variables there. I don't think you need to write what I'm about to write because it's already on there on one of the other questions. But we have one variable that's rating. And that was your response, where 1 equals strongly disagree, 2 is disagree, 3 is neither, 4 is agree, and 5 is strongly agree. So those were your answers. And then I'm explaining why people gave certain answers through this regression equation. And so this is like the output, and this is the input, what we're explaining with. And we're going to have a number here, and I'm starting to put the equation that's already on number 2. All right. But then we have a variable large size. That means for any one question, if what you're evaluating, if we describe the pecan as being large, this variable equals 1, otherwise it equals 0. So it's just an indicator variable. It turns to a 1 if it's a large pecan, turns to a 0 if it's a small pecan. Sometimes we call these dummy variables. We have a variable for improved. This equals 1 if it's an improved variety. Remember, that's the clones. And it equals 0 if it's just a native variety, when you just grow them from seeds. And then we have a variable, okay, that just equals 1 if the package says the pecans were produced in Oklahoma, and it equals 0 if it says it was imported from Mexico. And then finally, and so these are just describing what the pecan packages look like. But sometimes things about people can help explain their responses. And so I created a dummy variable or indicator variable for female. And so this just equals 1 if the respondent is a female and 0 otherwise. Look on page 2 where it shows some of these data. Here's how I organize these data. The first set of questions, remember that first question just refers to a large pecan that is the improved variety and is produced in Oklahoma. And notice here, so all of these first things shown here in the spreadsheet are answers to those questions. And so large size always says 1 because the first question evaluates large size pecans. Improved always equals 1 because you were just looking at improved varieties. Oklahoma equals 1 because you were just looking at pecans produced in Oklahoma. But then female changes from 1 to 0 based on your gender. So the first 4 respondents there were female because the female dummy variable equals 1. And then the 5th respondent was a 0 because that person was a male, and so on. And so what I did was I took all those answers to the first question, and then underneath it I put all the answers to the second question. Underneath it I put all the answers to the third question, fourth question, fifth question, and sixth questions. So number 1 says a total of 31 people took the survey. So this first stack of the first questions is 31 people. 31 people took the survey answering all 6 questions. So this is how total many questions were answered, but actually one person didn't answer one question for some reason. And so if answers, this is number 1, if answers to each question are stacked on top of each other, how many total rows of data are there in the spreadsheet? 31 people answering 6 questions each, but one person didn't answer one question. So that gives us 185 rows of data. You remember estimating a regression in 3213? And so you've probably done it before. I'm going to skip the how to do it and just talk about how we analyze the results. So number 2 says the regression assumes the model generating process goes by this formula. And so we're saying that the reason people give different ratings, 1, it has to do with the type of pecans, its size, what type of variety, where it was produced, and it also depends on things about the people. Here, I've just got their gender. You could, of course, add other stuff as well. And of course, this doesn't fully explain everything. There's some error in there, just from randomness, from things we can't observe. But this is stuff we can observe, and so we're going to use it to help explain ratings. And then what you do in a regression is you estimate these coefficients, the A0, A1, A2, A3, and A4. You estimate them, you get numbers, and what Excel does is it just gives you values for A0, A1, A2, A3, A4 that provides the best predictions of the data that you got. And for just kind of a prelude, look on page 3, and you can see the regression outputs. In that screenshot, there's a column that says coefficients, and the one besides intercept says 1.6317, meaning that's the estimated coefficient for A0. The coefficient for large size, which is A1 here, is 0.5619. The coefficient for improved is 0.0520. The coefficient for Oklahoma produced is 1.5323. And the coefficient for female is 0.2129. And what we're just going to concentrate on is how you interpret those coefficients. Two A says, suppose that the value of large size equals 0. The value of improved equals 0. The value of Oklahoma equals 0. The value of female equals 0. What type of pecan and respondent does the equation refer to, and what is the predicted ranking? So it's saying that every single one of these variables are 0. And that's telling us something about the package. So if this says 0 for large size, that means it's referring to small pecans. If improved equals 0, that means it's not improved, so it's referring to native variety. If Oklahoma equals 0, that means it wasn't produced in Oklahoma, so it was imported from Mexico. And then if female equals 0, what's the opposite of a female? Drindle? A male, or drindle, right. So when we want to take these survey results and predict how likely they are to buy different scenarios, we just go in here and plug in different values for those variables. All right? And so if this equals 0, well, then this whole term becomes 0. If this equals 0, this whole term becomes 0. If this equals 0, this whole term becomes 0. If that equals 0, that whole term becomes 0. And so rating just equals a 0. So that's the predicted rating for this type of pecan package and for a male respondent. So that's like a baseline. And it doesn't really matter what that baseline is. That's not really what you're so concerned about. The nice thing about what a regression does is that it's going into those survey responses and it's picking out patterns for you in a way that's really easy for you to interpret. So, and we're going to put these answers in a minute, but what this lets you come in and do is this coefficient A1, that's going to tell us how the rating changes when you go from a small pecan to a large pecan, holding everything else constant. Meaning we're just increasing the size of the pecans, they're still native, they're still imported from Mexico, and we're still talking about a male respondent. But that impact is the same no matter what the natives are or where it's produced or the gender of the respondent. That one coefficient evaluates the impact of the pecan size net of everything else. So even though in the questions the pecan size was changing along with all this other stuff, the regression picks out just the impact of the pecan size alone. That's what makes regression such a powerful tool for analyzing survey responses. Two B says, now suppose improved equals Oklahoma equals female equals 0, but large size equals 1. What type of pecan or respondent does the equation refer to? So now all the other variables are 0 except for large size. And so that's like we went from that baseline package and we just increased the size of the pecan. So what type of pecan are we referring to? Large pecan, native variety, imported from Mexico with a male respondent. So 2B's just like 2A, except just the size of the pecans got bigger. That's all it is. And what is the predicted rating? We still have A0. A0 is just a number. Now, large size does equal 1, so 1 times A1 is just A1. But improved is 0, so this becomes 0. Oklahoma is 0, so this becomes 0. Female is 0, so this becomes 0. And the rating is this. And so notice the difference in the rating in 2B and 2A is just A1. So in the previous question, the predicted rating was A0. Now the predicted rating is A0 plus A1, so it changed by the value of A1. And what's the only difference between this scenario and the last scenario is the pecan got bigger. And so that tells us, and I'm going to write this in a second, that A1 tells us the impact of going from small to large pecans on the rating. It's singling just the impact of pecan size. So 2C says, how then do we interpret the coefficient A1 tells us how the ratings change when the pecans are large instead of small. Here our value of A1 is 0.5619. And so when you increase the size of the pecans, people like it better. They increase their rating. How much? They increased their willingness to buy it. So that's good. People like the larger pecans better. And the nice thing about regression is all the interpretation of the coefficients go by a same thought experiment, a same general interpretation. 2-point D. Now suppose large size equals Oklahoma equals female equals 0. So we're back to small pecans. They're not produced in Oklahoma. We're still talking about a male, but now improved equals 1. So now we're not talking about natives anymore. We're talking about improved varieties. What type of pecan and respondent does the equation refer to? What is the predicted rating? So we're once again talking about small pecans, but now it's an improved variety. Imported from Mexico. Male respondent. And as an aside, what we just did is we looked at the impact of increasing the size of the pecans. And even though it seemed like we were assuming a male respondent at the time, and we kind of were, you get the same result regardless of whether you're looking at male or female respondents. So what if we said, well, now we're comparing the impact of a larger pecan size for females? Well, then this A4 would just be in both the equations, and the only change would be A1's large size. Conversely, instead of using an indicator variable for female, you could make the indicator variable for male such that the default is a female. You get the same coefficient values for A1, A2, and A3. So when I say, like when I'm about to say that A2 lets us look at the impact of the improved variety, and that impact is the same for males and females. And then our rating here equals A0. That's always there. It's just a number. Large size is 0. This goes to 0. Improved is 1. 1 times A2 is A2. 0 here, this term goes to 0. 0 here, this term goes to 0. And we just get this. And then remember, the predicted rating for 2A was just A0. The predicted rating for 2D is A0 plus A2. The only difference is the value of A2, and the only thing we changed was the type of variety. So that coefficient A2 tells us how an improved variety impacts ratings compared to native variety, holding all that other stuff constant. And somehow I went from 2D back to 2C again. That's nice. So I'll make this 2C again. Damn COVID. How do we interpret the coefficient A2? The value of A2 tells us how ratings change. When the pecans are improved variety. Instead of natives. And when I look at the coefficient estimates, A2 is 0.0520. That's a positive number, so going from natives to improved does increase the ratings, but not a whole lot. The coefficient for large size was 0.5619. coefficient for improved is 0.0520. So the variety, at least for y'all on these questions, didn't matter near as much as the change in pecan size. Now we've got another 2D. 2D is asking about the coefficient A3. And we're going to have a similar answer. So A3 is going to tell us how the ratings change when the pecans are something instead of something. And what's the answer there? What's the default when... So A3 is multiplied by OK. So A3 only matters when OK goes from 0 to 1. When OK is 0, what does that refer to? Imported from Mexico. And when it becomes 1, it's what? Grown in Oklahoma. So A3 tells us how ratings change when the pecans are produced in our lovely, great state of Oklahoma instead of imported from Mexico. And so when I look at those coefficients, the coefficient for A3, the coefficient for Oklahoma is 1.5323. That's very big compared to the other two coefficients we looked at. And so that suggests that according to these survey questions, that matters more to y'all than where it was grown matters more to y'all than the size of the pecans or the variety. Probably, this is Oklahoma, you've been conditioned not to like Mexico the last 4 years. So that's part of propaganda, right? Or maybe you just think they would taste better here. Maybe it's because your neighbors, you want to support them more, something like that. We don't know why. All we know is that ratings go up. E is asking about the coefficient A4. A4 is multiplied by the female indicator variable. So A4 only matters, it only has an impact on ratings when female goes from 0 to 1. And so when female is 0, what's that refer to, Jindal? Male. And when female is 1, refers to female. And so the coefficient A4 tells us how ratings change when the respondent is male instead of female, which may matter to you if you want to know who's more interested in buying pecans, males or females. The coefficient for A4 is 0.2129. That's positive. So that actually suggests that when you go from 0 to 1, A4 is positive, ratings go up, that males actually like pecans better. Just two more things and we'll leave early. You've got this regression output here. We just want to make sure we can interpret it real quick. And we've got to include statistical tests, but we're going to do statistical tests the easy way. If I give you output like this on a test, you know, we got numbers for coefficients, right? You'll never estimate a regression where the coefficient equals 0, like 0.00000. It won't happen. Even if a variable doesn't matter in reality, there's enough randomness in the data that some coefficient is going to be there. So I could have generated a random number, put it in the regression, and I'm not going to get a coefficient of 0. And so we need some way to say, is the coefficient big enough to take it seriously? And all you need to know in that column that says p-value, as long as the p-value is less than 0.05, you take the coefficient seriously. If it's greater than 0.05, you pretend like the coefficient is exactly 0. That's what I have in number 4. It says the regression results, including the coefficient estimates, are showed below. As a general rule, if the p-value for a coefficient is greater than 0.05, we say the coefficient is, in reality, approximately 0. If this is the case, which of the variables, large size, improved, Oklahoma, do not impact preferences for pecans? Now, who can look in that column of p-values and find a number less than 0.05? Or greater than 0.05? Either one. In the column under p-value, do you see any numbers greater than 0.05? Yep. Improved and female. All right? Okay, so. So this tells us from these survey responses that when it comes to what matters for people liking pecans more or less, the variety of pecans doesn't matter. Y'all are just as likely to purchase one that says improved varieties as you are native varieties. Gender also doesn't matter. This suggests that males and females are just as likely to prefer pecans. But it also tells us that the size of the pecan matters. Where it's produced matters as well. And so we now went to the last one, all things considered. What does the regression tell us about the impact of those things for preferences? We've already kind of answered part of that here. The variety and gender has no impact. And so now I'm just going to look at the two variables with a p-value less than 0.05. One that matters is A1 for large size and A3 for OK. The coefficient for large size was 0.5619. Coefficient for Oklahoma is 1.5 0.0323, and we know they matter because the p-values are less than 0.05. So we conclude people like larger pecans raised in Oklahoma production location is about 3 times more important. So when we went from being imported from Mexico to raised in Oklahoma, ratings went up by 1.5 about. When it went from small to large size, they just went up by 0.5 or 0.6. So while both of these matter, that location coefficient is about 3 times bigger, and so that tells us that location is the thing that really matters most, at least in how we described it here. You know, the definition of location here is Oklahoma compared to Mexico. If it was Oklahoma compared to Texas, it might not be the same thing. Well, Laura's not here. Should I call her to see if we should stop here, or?
You should.
You know her number?
No.
Does anybody know Laura's number? Okay. Okay. See you Wednesday.